These notes are on scientific notation. It explains how you write numbers in scientific notation as well as how to take numbers in scientific notation and convert it back into standard form. This is an example of scientific notation. Scientists use it in order to write really big numbers or really small numbers so that we can drop out all these placeholder zeros. Sometimes your calculator puts your values in scientific notation, so you need to be able to understand what your calculator is spitting out at you. Some background information: if you have just a regular number, either really big or really small, we call that standard form. And when you have a number that has a decimal location in it, times 10 to the power of some number, these are written in scientific notation. These notes will focus on how to go from this version into this version, and if I give you this version, how to go back into this version. Some details about a number in scientific notation. There are two parts of our scientific notation number. This part right here, it's the decimal version of the actual number. That is called a coefficient. And coefficients are numbers that are between 1 and 10. In other words, it means that there's one digit, then your decimal place, and then the other digits in your number. So for example, 2.46 is between 1 and 10, and 3.56 is between 1 and 10. The other component of your scientific notation is this times 10 to some power. This is our power of 10. That's what we call that. This exponent, this number right here, is going to indicate how many times we've moved our decimal place. It will also tell us what direction we've moved our decimal place. That's what I'm going to be getting more into, more in depth in a moment. But for right now, that's our power of 10 and our exponent. It tells us how many times we've moved our decimal. Now, let me go through the process of how to go from standard form into scientific notation form. So if I have a number that's fairly large, I want to shorten this down. So again, I need my decimal, I need my coefficient to be between 1 and 10, which means that I have this first digit, and I ultimately, in my coefficient, want my decimal to end up right there. Now, currently, this number doesn't have a decimal. This is where I want it to end up. I have to get it there first. So if I just look at this number, there's not a decimal in there. These are commas representing that this is 1,234,000. So I will assume that my decimal is at the end of my number. So it starts at the end of my number. I ideally want it after my first digit. So I would write my coefficient as my 1.234. I don't need to include all those zeros unless I'm looking at significant figures. Your coefficient counts for significant figures, a little side tangent on significant figures. All of the decimals that you need to include here is based on your significant figure number. If you need 4 significant figures, I would have write 1.234. If I only need 2 significant figures, I could have written this as just 1.2. Alright, so significant figures aside, I'm just going to practice with writing all my digits. I've got my decimal place after my first digit. Now I need to figure out my power of 10. So right now, my decimal is at the end of my number. I want it to end up after my first digit, so I'm going to count the places that are between those two decimal locations. So that would be 1 space, 2, 3, 4, 5, 6. I have to move my decimal 6 times in order to get it from its current location to where I want it. So I'm going to write that as times 10 to the 6th. Another example. Let's go smaller. Sorry, that's a scribbled out. I have a really small number. I want to write this in scientific notation. Again, I want my coefficient to be my first digit and then a decimal, and then the other digits that I need. This is between 1 and 10. And now I need to figure out how many times I move my decimal to go from here to end it up here. So, 1, 2, 3, 4, 5 times. I move my decimal 5 times to go from its original location to where I need it to be in my coefficient. So I'm going to say 5 times. Now, this is a number much smaller than 1. And this is a number that was much bigger than 1. So I can't have these be the same. I need to specify, hey, this one was smaller and this one was bigger. So, to represent smaller numbers, we put a negative in front of our exponent. This would be 2.46 times 10 to the negative 5th. That negative represents that this was smaller than 1. Now, let's do the reverse. So if I have a number in scientific notation, (4.32 times 10 to the 7th). My coefficient tells me the digits. My times 10 to the 7th tells me how many times I had to move my decimal. So I'm going to start by writing 432. My decimal is currently right there. And because this is a positive exponent, it means that this should become a really big number. Positive means that they're big numbers. Negative exponents mean that they're small numbers. So to make this into a really big number, I'm going to have to move my decimal to the right 7 times. So 1, 2, 3, 4, 5, 6, 7. There is my new decimal location. And all of these placeholders, I'm going to have to fill with zeros. So if I rewrite this number, 432, 0, 0, 0, 0, 0. I've got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. I'll put my commas in there so we can see that this is 43,200,000. Really big number. That's my standard form. If I have, 9.87 times 10 to the negative 3rd. Again, that negative means that my standard form is going to be a really small number. So I'm going to start with my 9.87, and I'm going to move this decimal 3 places, and in order to make it a smaller number, I'm going to move it to the left. So 1, 2, 3. There is my new decimal location. I'm going to fill in these gaps with zeros. So I would have 0.00987. Now, just as a formatting, I personally don't like it to start with a decimal because that decimal can get lost in your handwriting. It's easy to lose. It also doesn't look very formal to start with a decimal. So I tend to put a 0 in front as a placeholder to say that this is 0.00, just to say that it's less than 1. Then we don't lose that decimal somewhere. This 0 does not change our number of spaces. It does not change our exponent. We still have 2 zeros and our 9. 2 zeros and our 9. It's just a nice formality thing to make it look nicer. I hope that was helpful. Your practice is the scientific notation notes, or in your portfolio packet on page 15. There's a lot of different examples for scientific notation practice. Hope that was helpful. Come see me if you have questions.